So students, this is a question in which you see we are given the velocity time graph of a motion and you have to draw or identify correct position time graph, which one is the right answer. So if we look at our velocity time graph, let's draw it properly. Then it is something like this. All right. So if we divide this graph into the three segments, okay, so we can easily analyze each portion of the graph. So almost in this section of the graph, all right, we see that the velocity is constant. Okay, now velocity, we know that the velocity is the slope of position time graph. So if it is zero or if it is constant, so it means that the position or the displacement was covered by the object at a uniform rate. And if it is positive, it means that during the same time we must have this graph, the position time graph. All right, why? Because we see if you find the slope of this line, it will give you this constant velocity. Okay, now let's talk about the second segment of the motion, that is during previous to this time. So we see that the velocity during this is positive and decreasing. Okay, let's write it here. What we have observed, that the velocity is positively decreasing. It means that the position time graph cannot be straight line because slope is changing. Because whenever position time graph is straight line, any straight line at making any angle, velocity time graph is always gives us a constant value. But here we see it is decreasing and it is becoming zero. At this time it is becoming zero, so which means that we must draw this graph with decreasing slope. All right, with decreasing slope, and it should be horizontal at the same exactly the same time. If I draw a tangent line, so you can see at this point delta x over delta t is 0 meter per second. And before that, you can see that if you draw the tangent line, the tangent line steepness is decreasing. Okay, now let's talk about the third portion of the graph. The third portion of the graph, now you can easily understand what I'm talking about. I'm talking about this part of the graph which shows us that velocity is increasing. But how it is increasing? It is increasing negatively, which means that the slope delta x over delta t must be increasing. All right, and how it can be increasing, and what curve gives us a negative slope? Because all of the values during this time, all of the values, and even after that, all the values of velocity is negative. So which is only possible with the help of this curve. All right, because if you find the slope at any point by trying a tangent line, so you know very well that this tangent line will give us a negative value of rise over run. Okay, so it will give us delta x over delta t at this certain time will give us a negative value, and it is increasing. Okay, because at this point the tangent line is more steep. So last but not least, what is the last segment of the motion during which the velocity is once again a constant value but a negative constant value. So negative constant value means our line must be like this. Okay, because only this graph will give us a negative value of velocity. So rise over run, once again delta x over delta t is a negative constant value. Okay, which we see from the velocity time graph. So only one graph matches with this shape of position time graph, that is obviously option A.